All right, here we go with some lovely examples. And I know I've talked to a couple of you about having E in that function. Don't skip them. Learn how to deal with them. All right. Whoops, sorry about that. Letter A. We want the derivative. So I'm going to do the derivative of the first term. Okay. With this E in there, all I really need to pay attention to is this coefficient. The 2 will come down. So the derivative will be 8 e to the 2x, okay? And then I need to apply the chain rule to this piece here. So I'm going to add the derivative of sine is cosine. And I'm taking 3x plus 2, and because it's the chain rule, I have to multiply by the derivative of the inside, which is 3. So letter A is done. Okay? So letter B. All right, we have a product here, right? So u is equal to e to the x, and its derivative is going to be e to the x. V is going to equal sine x, and the derivative of sine is cosine x. So the derivative is e to the x times cosine x plus e to the x times sine x. To write it, that's not incorrect the way it's written, but we can write it a little more simple if we factor out that e to the x. So it's just cosine x plus sine x. A lot of times when we're going through these, all of a sudden an identity will fall out. So you might, if this had been squared, so you might have been able to come up with the Pythagorean identity and simplify it a little bit further. But that's actually where this one ends. So, letter C. Letter C, I've got a little bit of a mess. I've got cosine x that's being cubed. And I think it shows up a lot better as being the chain rule if I write it like that. And that's being multiplied by sine x. So it looks like I'm doing the product rule, and in the product rule I have to do the chain rule. So u is going to equal cosine x cubed, and that means its derivative is 3 times the cosine of x, and then I have to multiply by the derivative of the cosine x, which is the negative sine of x. Notice I just put the negative sign out in front, so I didn't have to write it twice. V is equal to the sine of x, and the derivative is the cosine of x. So now we do our multiplication. So that gets me cosine x cubed times cosine x, so that's going to be to the 4th power, plus negative 3 cosine x sine x times sine x. Okay, I have a cosine that can be pulled out of both of these. I can factor cosine out. So that equals, well, we don't have to do that. We actually have cosine squared that could come out truthfully, because that would be cosine squared minus 3 sine squared. It doesn't do us any good anyway. So we'll just leave it as cosine to the 4th of x plus, or actually I want to change that to minus now. Now I realize that that term's going to be negative. Okay, so that'll be a minus. The only constant I have is 3, and then I have sine squared. What happened here? Thought I was going to get a cosine squared. Oh, it is. What did I do wrong? That's what I did wrong. I forgot this piece here was supposed to have a squared on it. So that means this piece here should have a squared on it. There it is. All right. So that gets me cosine squared x sine squared x. All right, and our final one, letter D, S of t is the natural log of the sine of t. This is a chain rule, okay, because we have a function inside another. So the derivative is going to equal, well, what's the derivative of natural log? It's 1 over x, but our x in this case is sine of t. And we're going to multiply that by the derivative of the sine, which is the cosine of t. So this thing is equal to the cosine of t over the sine of t. Now, they would probably accept this as the answer unless they told you to write it a different way. I can write this in terms of tangent, truthfully, because this is the inverse, the reciprocal of tangent. So I could write this as tangent to the -1. That's the inverse, or reciprocal. Or I could write it as 1 over tangent of t. Basically, all three of these are synonyms. They're saying the same thing. Okay? All right.